preparing the structural layout plan according to the architects, right? Um, I hope I can finish this chapter by today, within 2 hours. Okay, by 12 o'clock, I have to stop. Okay, all right. Okay, so if you look at this slide here, okay, this is about on the project procedure, which involve several stakeholders or involve many consultants, which is the first involvement here. It starts with the clients or buildings owner, right? For the projects, it starts with these clients. Sekejap, sampai sekejap. Okay, then this projects owner, okay, or this client will hire any consultants, okay, to develops, to build their desired buildings or projects. Okay, in this consultant consists of few members here, okay, many members here, which is the first is lead by architects. Okay, normally the projects lead by architecture. Okay, so then which is from architect, they will come up with the drawings, with the plans, with the layouts. Okay, according to the requirement from the clients. Okay, what the concept they want. Okay, uh, any requirements that they want. Okay, based also on the client's budgets. Okay, then the other is involved by the land surveyor. Okay, this also is very important themes. Okay, to do the levelings, the topography, the locations of the buildings, uh, how about its facings, okay, the directions, positions, and so on. Okay, and then this is a civils and structural engineer, okay, which is will responsibles on technicals, on structurals part, okay. um, which is this is you actually, okay. You will be in this post, okay, civil and structural engineer. Then there will be also other engineers, which is mechanical engineer and also electrical engineer, which responsible on for example for elevator, for power systems, air conditions, apa lagi yang berkaitan dengan mechanical and electricals lah. Okay, and then quantity surveyor here. Selalu kita panggil QS, QS. This will responsible with the costing kan, BQ, if you familiar with the BQ, which is bill quantity, all the costs, all the materials, for the workers, hours, labor, and so on. Basically on the budgets, on the costings of the project. So last theme here is the contractor. This also the important stage, okay, which the one who will develop, constructs the projects, okay. So all of these member here will come up with their own drawings. Okay, we come up with own drawing, but the originals idea, the originals drawing is come from architects. So that means from the architects, the land surveyor, civils, mechanical, electricals, quantity will follows by the architecture's drawing. So this you can go through it's more on details. What's the jobs or tasks for every team member. Okay, so if you look at here, architect and engineer here, which is both will participate in designs the building structure, right? Okay, tak kisahlah for housings, for schools, ataupun dewan, hall, or for the shop lot, everything's lah. Okay, which is architects and engineer will work together, which is it starts from the architect's designs. Okay, they will draw the plans of building or might be bridge or other structure, which is the goal for the architect is to satisfy the customer's requirement. Customer nak apa? Nak bangunan macam mana? So they have to follow. Okay, so making the appearance of the structure, liking and perform or quality work. It's more on aesthetic. It's more on idea. The idea might be a part of it come from the clients and then will enhance by the architects and so on. Okay, so then this is apa ni, you punya post lah kat sini, which is civil and structural engineer, responsible of applying what architects designs, what's their idea. Okay, you have to make it real. Okay, apply through it to the constructions. Okay, so the goal for the civil and structural engineer is to ensure that the design functions and safe to be used during its lifetime. Okay, so that's our responsibles. So other engineers siapa tadi? Electrical engineer, right? Okay, for lighting system, itu dia punya scope of work lah. Okay, and then mechanical engineers is more on machinery, right? Elevator, plumbings or any machinery systems. Okay, so that is a job or task for mechanical and electrical engineers. Okay, so that means here it shows that every architects or all the engineers have their own responsibility, have their own scope or limitation of work. So masing-masing buat kerja masing-masing lah. Architects do their own job and then pass the drawings to the civil and structural engineer, pass to the mechanical and electrical engineer. Okay, so the key difference here is which is architect focus on aesthetics value, okay, on designs of the building, while we as the engineer focus on technicals and structural side. Okay, this is I think this one repeat from the first slide here, which is more on aesthetic, okay, especially for the architect here. All right, so for the first drawing or the original drawings from both from architect and engineer, we call it as a technical drawing or blueprint here, okay, or blueprint. Okay, kalau you ada ini peluang, any opportunities, the original one memang the drawing is blue color. Okay, so we also call it as a blueprint. That's the original one that we submit to other engineer, that we submit to the contractor. Okay, so what's the importance about the drawing is it will have a scale drawing. Okay, it should be scale drawing because it will apply at sites, kan? Kalau you mentions the size of beams 200, 400, it should be scale. Is it millimeter or what inch units or any unit? It should be scaled properly. Okay, same goes with the dimensions, the length, the height. Okay, it should be have all the informations, okay, the measurements in the drawing. So The selections materials also is very important, especially in the architect's layouts. Okay, in the architect's drawing, there will be most of it. There will be selections of materials. What types of materials going to be used for roof system? Is it timber or steels member? Okay, same goes for the might be for other fittings facilities such as window. Kan dia mention window tu daripada apa ni, what's the material for that window? Is it glass? Apa ni, ataupun is from the timber frames ataupun door, everything. So all of these materials, okay, normally we will get the informations in the architecture drawing. This information is very important for us to know, right? Because we want to know what the density of the material. If we use timber, what's the density? If we use concrete, this density will be calculated in our designs. Okay, if you remember, we have load of GK, right? Of QK, variable loads or permanent load that you have learned in apa ni, last weeks, right? Okay, so an engineer, okay, we as an engineer will take the blueprint presented by architect. So in order to determine is it possible or not to be built, kan? Imaginasi architects ni kadang-kadang di luar kita punya apa ni, um, apa ni, calculations kita, kan. Lalu kita design biasa-biasa je, tiba-tiba architect ni come out dengan apa ni, special design apa ni, with less numbers of column, let's say. But we as engineer, once we analyze, we couldn't make it. It's not possible to construct by just a few columns, kan? So this is the things that we look for. This is our responsibilities, okay, to ensure that that drawing, is it possible or not to be built, okay, and then so what the materials to be used, kuat ke tak nak guna timber, kuat ke tak nak guna steel with that long span, let's say for the long span it's suitable to be used steel, so we have to discuss more on it, okay, with the architects. Some of the proposal by the architects we can do some changes. Okay, let's say the sizings, dia nak column size 200 kali 200. Okay, but once we try to design by using that size, it couldn't be. Okay, it's not safe. There will be apa ni, huge bucklings and so on. So we have to come up with other size. Let's say we have to increase the size. Okay, so that is some changes, some discussions that we should work together with the architects. Okay, what else here? Okay, so a lot of decisions here. Okay, you have to go through during the designs of the structure, okay, in order to ensure that the structure is safe to be used up to, kita design up to 50 years, right? So that is our goal. Okay, so this is 3 different phase that involved in the projects. So the first, planning. So planning selalunya carried out by architects. Dia yang plan dulu. Nak rumah bentuk macam mana, berapa keluasan area according to the apa ni, building owner, okay, punya land, everything lah. Okay, so the first plan, the first drawing, it come out from the architect. So they will determine how the arrangements, okay, how the layout of the building, okay, basically should meet the client's requirements, kan, dia punya bangunan, tapi the idea or the discussion should be both lah by the clients and then by the architect. So they will look into aesthetic value or environments and also the budgets. Okay, also the cost of the buildings. Okay. Then the second phase, barulah kita. Okay, we as an engineer, we are in this phase which is design phase. Okay, we have to come up with our structural design. Okay, especially for us, civil and structure engineer. While for the mechanicals and electrical, they will come up by their own layout. Okay, for the plumbing systems, for the electrical systems, kan? You nampak banyak pipeline, so everything comes from mechanicals and electricals engineering. So they do their own part here. So that's mean in the design phase, not only include us, okay, it also involve other various consultants. So the last phase here, or the last stage is construction phase here. So kalau kat sini, kalau you masuk dalam design or consultant, so you will be the consultants engineer lah, do the designs, duduk kat bilik office, aircon. So sometimes you will also have to go to the sites. Okay, but if you work at the constructions, so normally we call it as a site engineer. Okay, kat sini lain dia punya, you punya scope of study. You more on supervisions, okay, which is you will supervise, okay, the works that should be constructed according to the structural drawing, according to the drawing of comes from the consultants, engineer. Okay, so what the sizings, the positions, how deep the pilings, the size, the numbers of reinforcement should be sufficient enough, should be exactly according to the drawings. Okay, so that is difference once you work at the construction and work at the consultants. So that is your choice. Okay, you nak kerja kat mana, nak consultants, you will have a experience on design process, on analysis. Okay, use the software, everything. Kalau dekat constructions, you have more on experience on technical, okay, at sites, okay, but might be a lack of experience on designs, right? Okay, so this is the task of structural engineer. Okay, what you should do, what's your scope of work here. So first, selection of the most appropriate structural system. So kalau nak buat rumah, so it should be just a skeleton systems, right? Kalau nak let's say kilang, you can go for frame system. So you have to know, you have to understand what the systems that you have to design. Okay, and then idealize of the structure into frames and elements, how you idealize from the real structure, okay, to be as a your sketch of load and everything. Okay, let's say in this stage you will come out with the loadings, right? How about its supports, what's the loads that apply on it. So that is in the stage 2 here, estimations of loading. Remember, we have a GK, we have a QK to consider. So can you remember what is GK? We have learned it last week class. You had learned in our last week class. What is GK? Anyone?
Permanent load.
Permanent load, right? Contoh safe weight, brick walls, so what as ceramic tiles, everything, any materials, any structure that is permanently at that structure. So that is GK. So QK, which is trend change, okay, within time, people's the functions of that area. So that is the QK. Okay, so this is the things that you will do the estimation. What's the load, okay, from the GK, and might be other loads from the QK. Okay, so if have any point loads from the columns or any point load from the secondary beams and so on. Okay, from these estimations of loading, okay, you will come out with this third task here to analyze, to determine the maximum member. Okay, dia punya moment shear berapa. So you will not go on torsions. So we just focus on moment and shear here. Okay, so from, if you can remember from this distribution loads, you can come up with the bending moment diagrams, right? Let's say this is the bending moment diagram. So what the maximum value of moment here? This maximum value will use in the calculations in order to provide the reinforcements. Okay, how many reinforcements? How many main reinforcements that should be arranged in the beams or columns or slabs, what the size, which is according to the moment maximums. And then shear here. Okay, so you have to come up with shear force diagrams. Okay, so this is shear force diagram. So you can refresh balik yang you dah belajar sebelum ni, because all of this will apply in this designs process. Okay, yang basics ni kita tak ajar balik lah, macam nak plot shear, macam nak plot bendings ni. No, we will not repeat this one. Okay, so you have to do your exercise. So kalau in this case of load, so how about its BMD and SFD here? Okay, let's say from this SFD, what's the maximum shear here? Okay, let's say this is the shear maximum, V max. So this V max is very important for you to decide the shear lengths. Right, so this V max will use to design the shear lengths. What's the spacings between the links, what the size or diameter of these links here. Is it using size 8 or size 6? What's the spacing? Is it 50 mm or every 100 mm? Okay, for the spacings of the links. So if I sketch for the beams here, okay, for a simple understanding, this is the main bar here. Okay, so this main bar is come from the moment maximum value, while the shear links here, okay, or might be you want to put along the beams here. So this shear link is come from the shear maximums. Okay. So number 4, design of sections. Okay, design of section and reinforcement arrangements. Once you already provide the reinforcements here, what's the numbers, what the size, so you will come out with the sections of the beams, right? Let's say these beams provide with 2 numbers of height strength bar with a diameter of 20. So that's mean there will be in the cut sections of beam, there will be a two bars with diameter of 20. Okay, let's say for the links. Okay, for the links, let's say the links here use mild steel, which is R. Okay, the symbol H symbol for height steel, R is symbol for mild steel, which is size 6, let's say diameter 6, which will arrange with the spacing here about hundreds. Might be so in the cross sections here, you will see the links here. okay, with the size of R600, while for the main here is a 2H20. So this is how we do the sketch. Okay, this is how we do the sketch, which is this is the last stage in order to produce the layout plan, in order to produce the detailed drawing. So the detailed drawing, it means the arrangements, the sizings of the structure. Okay, it can be beams, columns, or slabs. So this is all the tasks for you, okay, to be as a structural engineer. It starts from the selection of materials, and then you have to estimate the loads. You have to analyze what's the maximum moment and shear. Okay, from it you can design. You can come up with the sizing, with the numbers of enforcement, and the last one you have to do the sketch. Okay, you have to draw the detailing and so on. So I've mentioned before, kalau consultant tu jenis company yang company yang besar, if you work at a big company, there will be a draftman. Okay, so that means you just submit to them, submit to the draftman's the sketch of your details drawing here. So they will do in the AutoCAD and so on. Okay, in order to produce the structural layout plan. Okay, so what information that you will get in architecture drawing, kan? So what is to be built? Di situ kalau dalam drawing you akan lihat dekat dia punya title block, okay, we mention is as a title block. Dia ada frame kat sini kan. Ni nanti adalah gambar rumah. Right, okay, ada gambar rumah, tak apa-apa sajalah drawing, dia ada layout lah nanti, all the space, which one the bedroom, kitchen, everything, and there will be a logo of the company, and then there will be a descriptions of the project here. This is what we call it as a title block here. Okay, so in this title block there will be information what is to be built. They will have a description. Let's say, okay, projek apa? Sekolah, untuk buat sekolah menengah Parit Raja, kan? How many blocks? Berapa stories, kan? First just single story or double story. Okay, so where it's to be built? There will be a location, dekat lot berapa sekian, dekat taman apa. Okay, so all the information, how it's to be built. So how it's to be built, there will be according to the budget also from the clients. Dia nak buat apa? Precast, okay, ataupun just conventional constructions, which is all the materials will be prepared at site. Right, so kat situlah dia mix concrete, kat situlah dia bengkokkan besi dan sebagainya lah. Okay, contoh macam buat rumah lah, just for a commons building, especially for the housings, kan. So that is information that you have to know, that you can get from the architecture drawings. Okay, so there will be many views of the structure. So ada site plans. Okay, site plans, this is very important in order to know where is the location of that house. Dekat lorong mana, dekat lot nombor berapa, nanti tersalah buat rumah dekat tanah orang pula, kan. So that is important site plan here. And then floor plan, so kalau double story buildings, kan, so this is the ground floor plan. Okay, this is the first floor plan. Okay, and then this is the roof plan. So that means for the double story here, so in the architecture drawing there will be these three floor plan. Okay, ground floor plan. So ground floor plans mungkin lain dia punya arrangement, spacing compared to the first floor plan. So every plan must have their own drawing. Okay, so if you look at here, I've mentioned here ground floor plan, first floor plan, and then roof plan. There's no floor stated for the roof plan here because there's no floor there. Okay, kalau you tengok roof tu, tak ada floor pun, siapa nak duduk dekat floor, dekat roof levels, right? Kalau ada slab pun, it just provide for water tanks, let's say, or any storage or any mechanical storage and so on. So that's why normally for the drawing, they will mention ground floor plan because there is a slab, okay, within this level. This one also first floor plan, but roof, we just mentioned roof plan. Okay, so kalau banyak for the high rise building, there will be many drawings, many plans, which is you should not miss any information inside it. So you kena be careful, you kena details, look every information, each of the plan. And then in the architecture drawing also provide the elevations view. Macam mana pandangan dari depan kan, dari belakang pula macam mana. Okay, and then also side, there will be a right side or left side. Might be the right side, they will have windows, but the left side, there's no window. Got a staircase and so on. So every sides, every elevation should be checked. Okay, should be in details. Okay, and then also there will be a sections. Let's say there will be a cut section here or cut section here, which is you can see what's inside the buildings. Kan katalah ni kalau drawing ni actually you lihat daripada top view kan, daripada top view you nampak semua dia punya arrangement, spacing. Let's say you cut these sections here, so you will see what inside in the buildings. Nampaklah dia punya beam dia kan, for the first levels and everything, nampaklah dia punya brick. So this is what is mean by the cut section, which is you can see details what inside the buildings. Right, ni contoh for the site plan. It's about on topography, landscape, so any utilities or site work. Kadang-kadang you nampak ada landscape kan, ada nampak pokok, lepas ada kolam pula. So this is a site plan here. Kat mana? Dekat Batu Pahat nak buat projek ni kan. So zoom lagi, so dekat lorong mana, dekat kampung mana, dekat lot berapa. Okay, so that is the information that you get from the site plan. So nampak nombor lot. This is the proposed building here. So you tak nampak sangat ni drawing selalunya besar, so once I will make it comprise, it's a bit blur kat sini, tak nampak. Okay, don't worry. So for your projects, for your first assignment also, there's instructions for you, okay, to come out with the architecture drawing. Okay, I think by 11th, the view of the instructions tu akan appear dalam auto system. I set pukul 11. Rasanya lah I set pukul 11. So which is your first assignment will be on this chapter 2. Okay, this first assignment actually is a part of your project. Tak adalah buat assignment lain kan. So we just focus for the project. So I extract sikit daripada project ni to be as your assignment. Okay, which is you have, each of the group member, you have to come out with the architecture drawing. And then from the architect drawings, you have to make it as a structural drawing. Okay. Okay, so floor plan here. From it you will see all the informations. Okay, bukan saja structure, elevations. Dia juga tunjuk fitting lain kan, window, door opening here. Nampak macam remeh door opening. So katilah nak buka keluar ke, nak buka ke dalam ke. That is very particular in terms of aesthetic value for the architects. Okay, so is it slidings ke atau pintu biasa ke? So all the materials here, all the specifics materials here will be mentioned in the architect's drawing. And also for any features window, dia nak jenis macam mana? Is it slide ke atau buka ke? And then how about the thickness? How about the tilings? Okay, how about the roof systems and everything? Okay, so that's it in architect. So if you can see here, this is example of architecture drawings. Okay, so dalam architecture drawings, it will mentions what's the title of that drawing. Ground floor plan or first floor plans. Okay, and then look at here. Okay, there's a grid line in vertical direction and also in horizontal directions here. Okay, let's say for horizontal, it use A, B, and C. Okay, for vertical direction, it use numbers here from 1 to up to 12. Okay, according to the arrangements. Okay. So it mentioned here, this is a dining area. Okay, this is a nursery, I think. This is the corridor, toilet, and everything. This information is very important for us as a structural engineer, because from this information, from these labels, from this space, we know what's the functions. We know what's the QK that should be applied on this slabs, right? Kalau dining mungkin QK dia just 1.2. So kalau nursery might be QK dia about 4 ke atau corridor. So this is very important information for you to know. Okay, in order to estimate the loading. Same goes for brick wall here. If the drawing mentioned there's a brick wall along of this line, so that means there will be a loading, okay, from the brick wall, the loading of the GK, right? The self weight of the beam, also the self weight from the brick wall also. Let's say there's no brick wall in this line, so that means in your calculation there will be a zero load from the brick wall. That means you have to consider only the safe weight of the beam that made of concrete, let's say. Okay, let's say this have a brick wall here. So look at here, there will be a difference loading that apply on this line of the beams. Okay. You also have to know where's the location of brick wall in order for you to provide the beams. Remember, whenever have a brick wall, there will be a beam will support the loads. Let's say this is the brick wall. You must provide the beam along the brick wall. Okay. Kan, lepas ni nak provide structural layout plan. So kat mana nak letak beam, kat mana letak column. So this chapter will give you a knowledge, information on how to come out with the structural layout plan. Okay, so nampak pintu ni kan. So nampak ni pintu ni maksudnya dia buka beginilah ke dalam. So some of the symbol you have to understand. So this is the staircase. Okay, so nak naik mana ataupun kat sini lah turun ke dan sebagainya. Okay, so this is all the information. Actually all the materials that selected by the architect, all the size also select by the architect. Let's say for the beam, tadi kita mention kan kita nak decide berapa size. So normally architects will come up with their own beam size. So we have to follow the beam size. Tapi dia tak come out lah dengan reinforcement sizing, diameter tu tak sampai situ lah. It's not their task. Kita punya responsibility, right? But on aesthetics, on appearance, they want the beams not so big. Kalau kita mungkin kita nak design perceptions bigger will be more safer, kan? Lagi besar lagi kuat, lagi besar lah, tak roboh, tak collapse, kan? So but they have their own view, okay, on what they want on the appearance of the building. So most of it they will come out with the size of a beam, size of columns, okay. Apa ni, and also apa ni, the heights of the structure and so on. It's okay. We can try to analyze the size that proposed by the architect. They say they want 200 times 400 for the size of beam, kan? Dia nak dalam architect dia nak 200 kali 400 for the ground beams. Okay je kan? Kita try lah size for this 200 400. If the size is okay to cater all the loads, if the size, once we check, pass to all the serviceability of deflections, cracking point, okay, so we agree to use of this size. But if we check with the size, it's not safe for the deflections, might be, okay, at the end of our checking, this size is not sufficient to for the deflections, might be. So we have to discuss with the architect that we have to increase the size and so on. So the architect must follow us, must follow our analysis because of the safety. Okay. So ni first floor, so might be there's some changes, arrangements, sizings might be it's not same, but what should be maintained here is the grid lines. Kalau first tadi start grid lines 1, which is start from this position, so same goes to other layout, same goes to other levels. Okay, this one should be maintained. Janganlah ground floor dekat break the first this wall is A, nanti dekat grounds this wall, the same wall, okay, it start with the B. No, this the grid line should be same, okay, for all the layouts. Okay, this grid line is very important once we apply at sites. Okay, nanti contractor tengok kenapa ground floor apa ni grid line dia lain dengan first floor. So which one actually they have to refer. So we also come up with a structural drawing according to the grid, this grid line. Kalau grid line architect 1 to 12, jangan kita ubah-ubah pula, tak nak lah, tak best lah nombor ni kan, nak gaduh pula kan. Kita nak start sini apa ni, kita nak buat sini start from A, kita nak sini A, it should be A to Z. This one lah baru 1 to 3 kan. Let's say this one 1 2 3. No, we couldn't do that. We have to follow the originals drawing from the architects. Okay. So this is the roof plan. Kalau architect will shows all the arrangements of the roof systems. So ni tak nampak sangat apa size, okay, for the trusses, member, materials apa, and then roof systems ni nak guna apa, metal deck, nak guna zincs, ataupun open space, just a transparent fiber ke and so on. So all this should be in your roof plans. Okay, all the informations. Okay, so ni ada examples lah. Okay, let's say for the office here, sometimes they will have a additional here 2B. Okay, let's say 3, so ada 2B kat sini. This is 2. Maksudnya mungkin dekat grounds ada 2A. Kan? Awak nampak 3. Ini the main grid line. Okay, 3, 4, 5, 6. Dekat sini ada 2A. Kan? Bila dekat first floor dia ada sedikit perubahan. Let's say 2A, kalau grounds ada dinding kat sini. Tengok balik. Staircase ni 2A. Staircase yang kat bawah kan, dari bawah naik atas, dari bawah ada 2A kat sini. Tapi bila first floor kita dah tak nampak 2A, kita nampak tangga yang kat atas pula, which is other dimension, other lengths. 2A kat sini. Okay, bila first floor kat sini dia punya 2B untuk tingkat atas, untuk staircase tingkat atas pula, which is 2B here. Okay, so you nampak how the changes, the arrangements. Okay, but number 3, 4 here, all this one maintain. Okay. Okay, might be dekat tingkat atas pula, tak ada pula 2. Tapi yang the rest is maintain at its own directions or positions. Okay. Okay, alright. So terus pergi elevation, which is about apa ni? Front view or back view. Okay, kalau nampak front view here. Nampak simple kan? Alah, senang je nak lukis ni kan. But how they arrange, how the architects arrange by their concepts. Let's say this is geometrical concept, which is all should be in line. Contoh lah kan, dia ada konsep dia. Nanti kan konsep apa ni, ada curve, dia punya apa ni, dia punya systems lah on come up with the idea of drawing. Okay, let's say this is all the window, door should be in line here. Kadang-kadang kita nampak ada rumah tu, kadang kan korang pergi mana-mana lalu, kadang-kadang tengok rumah tu macam pelik pula rumah tu kan. Pokok lah kan, dulu korang selalu lukis kan, pintu sikit punya tinggi kan, tiba-tiba tingkap alahai kecil gitu kan, katalah. So might be this is not the concepts, the idea from the in line with the architects, right? So should be in line with the door, might be kan. So nampaklah dia punya apa ni konsep kat sini. So the in this elevation you will see the whole of the building from the front view. Okay, you will see all the grid lines here, maintain here. Okay, maintain kalau dekat layout, so nanti come dengan layout, nampaklah dekat sini apa. Kalau layout, nampaklah kat sini actually apa, tangga kan, kat sini classroom. Kalau dalam layout, if you see it from the top view, so from the front view, the scale is maintained. Layout kalau start from 1, sini pun sama. 1, 2, 3 and everything. Okay, so this is the height of each of the level. It mentioned here, this is ground floor level, first floor, second floor, okay, top of roof beam level. So dia ada parapet dan sebagainya lah. Okay, so ni kalau dari belakang. Kalau lihat dari depan, the number 1 is start from the left, right? 1, 2, tap. Katalah you duduk berdiri kat depan apa ni, sekolah kan. So you will see this view. So what happen if you go back, okay, pergi belakang, so there will be a different view of this grid line, which is the grid line of 1 is from your right side. Okay, so you pun dah belajar AutoCAD kan. So elevations, right side, this is left side. Kalau right side ada apa ni, let's say balcony ke, ada apa ni, air condition, storage or tingkap apa sini kan. Kalau left side lain dia punya view. Okay, so this is very important details for us to design also. Kadang-kadang kita tak nampak sangat that's structure from the top view. So then we have to check the other sides. Nak confirmkan, oh dia punya thickness ni kalau from the top view, okay, so kita tak nampak pun thickness ni kan. So nak darab ni berapa concrete ni kan, berapa per area. So we have to do the checkings on other elevations, okay, to analyze the sizings, the height especially. Okay, for the front view. So nampak how the architects draw kan, cantik kan, nampak bangunan biasa je. So the staircase, how the mirror concepts, okay, with the right and left side here, the arrangements, okay. Okay, ni you boleh go through. Ada soalan tak? Ke terlaju? Any questions so far? Yuhu, any question?
Setakat tak ada, doktor.
Okay.
Tak ada, doktor.
Pukul lah korang tertidur kan. Pagi tadi bangun sahur pukul 3. Kan? Okay. Okay, then cross sections. Ada juga view from the cross sections. Let's say this is the section X1. If you look at from the layout, pergi layout. You nampak kat sini. Kan ada Y kat sini. Actually, this is the cross section. So nanti akan ada drawing sections Y. Same goes for this X here. There will be other drawings to shows the cross section of X. You just imagine if you cut these sections, okay? Katalah you cut these sections. That mean you punya mata tu will see from this view. Okay, you will see from this view. You akan nampak these cut sections. Let's say this cut section, you akan nampak what inside the buildings. Okay, same goes for these sections. So you nak akan nampak bumbung dia macam mana kan. So how the interior structures in the building. Contoh tadi. Okay, so from sections X1, okay, you will see from top to the bottoms for every levels. You nampak staircase here, and then you will see also all this beam. Ni let's say the size proposed by the architect. Kalau dia propose the size for structure tu kita punya right. Structure tu kita punya responsible. Tapi dia propose, tak apalah kan. Tak gaduh pun, tak apa dia propose. We will follow that size. We will check, is it suitable or not, sufficient or not to do, to use that size. Kalau tak, it's not sufficient for that size, we have to change the size. We have to give a suggestion for the architect that the suitable size, the safest size will be blah 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 blah. Okay. So from the sections here, you will see the beam here. You nampak sini. So all of this beam here, kan? Kita appreciate lah how beautiful is the structure, right? Kan? Nak menang juga tu. Okay, and then we can also see the slab here. Okay, for every for every floor. And then we can see dia nak size ni bukan suka-suka je dia nak propose the size. Rupanya it should be standard for the architects to provide the shielding kan. Katalah ni kita nak size besar, nanti shielding kat sini pula. Katalah you nak propose size besar kan, nak selamat ni pasal kan, nanti shielding kat sini. So how about the clearance here? It will affect the space, okay, and that the architects wants, the appearance that they want, the spacings, okay, that also the clients want and everything. Okay. Same goes for the columns. Okay, so architect suka kalau columns tu tak nampak, which is flush with the bricks. Or what it mean by flush? That means you will, you will not see any columns. Let's say inside your rooms. Kalau you tengoklah keliling you punya bilik kan, nampak tak column? Semua every corner it's like from wall to walls, right? So kalau that means the columns will follow the size of bricks. It will follow the size of brick, which is this is the size of brick. Let's say 200. So the column also follow the size of brick here. Okay, this is the columns, and also this is the brick. So that's why you couldn't see any columns. This mostly idea or requirement might be from the client or architect. So we can use this size to the analysis and so on, and decide is it possible or not. Okay, for these sizings. Kalau you nampak columns tu, that means this is a brick wall, so might be apa ni, the column will be bigger here. Okay, compared to the brick. So nampaklah apa ni, the existence of the columns there. Okay, that is the difference. Is it flush, the column flush with the wall or not? So there are also sections YY here, which is you cut from the sides. You will see the staircase here. This design staircase is also our job, but it's not included in this chapter. You akan belajar design staircase ni next semester, might be in the subject of reinforced concrete. Okay, so nampak kat sini the platforms, right? Mesti ada platform here. Dah naik penat ni, berapa tingkat ni, tak ada lift kan, dah naik berehat kejap dekat platform. That is one of the functions of the platform actually. Tak adalah tangga ni terus naik ke atas. No, it's not practical. So it's not practical. So that's why this is standard design of the staircase here. It will support by this column, will support, this is the apa ni, the top level, and then the bottom also support by the column. So that's when this is the platform. There will be a steps here and then also the platforms here. In the design, you will also need to design what the suitable steps, the practical steps. Okay, what's the distance here, the rise height here, in order to provide the comfortables. Okay, whilst people go upstairs or downstairs using the staircase. Kadang-kadang you pernah rasakan nak naik tingkat atas tu rasa macam nak comfort lah dengan tangga tu kan. Dia punya steps tu tinggi ataupun terlalu pendek, ataupun dia punya steps ni terlalu kecil, you punya kaki dah lah besar kan, ataupun nak melangkah tu ada steps ni, dia punya rise dia is too high, it's too small. So everything should be designed actually, okay, to provide the suitable facilities, okay, to the buildings, to the peoples, okay, in the buildings. Okay, from the cut section also you will see the trusses. Dalam layout tak nampak. Dalam layout nampak line je kan. Tapi from the cut section you will see this member. Trusses pun you kena design nanti kan. You have to know what's the height, what's the size and everything. Okay. I terus jump into this slide. Okay, so this is important things for you to know on how to decide the positions and orientations of the column. Okay, for the first one here. Nak letak columns ni, nak letak kat mana kan? So you have to know some of the tips and also it from the experience, or might be you can follow the architect's proposals in the drawing. Okay, katalah architect mentions, okay, in this layout, let's say for this classroom, okay, in the architect it will mentions this is the point for columns. This is the point for columns. Okay, mostly the columns will provide at the corner. So that's the first tip. Column should be provided at the corner. That corner is actually the intersections of the bricks to bricks. Same goes for this T intersections here. Can this brick, this brick, this brick. How to tie all the directions of the brick? It should be based on the columns. So that means the reinforcement will be continuous to this column, the reinforcement will continue to this column, this reinforcement will continue to this column. It's back on the basic thing of the stability. Okay, on the stability. You kena ikat lah, okay, nak bagi kukuh, nak bagi kuat. So that the tips, the column should be placed at the corner, okay, at the corner or any intersection. So kalau lihat, let's say this is the positions columns that provide by the architect. Okay, you can just follow which is this beam, that means will support, this beam will support by only 3 columns, right? And then there will be a secondary beam here, which is supported by beam by beam. Remember, the main beam is supported by columns to columns to column. Kalau secondary is supported by beam to beam. That means the load of this beam will transfer to this main beam. There are 2 secondary beam here. That means there will be a point load from first secondary beam and then another point load from this secondary beam. This is how you idealize the load, idealize the support, the for the estimations of the loading. So ni kalau first step ni salah buat, salah lah you punya calculation, kan? You have to know which load apply. Is it as a uniform load or as a point load? So this beam have its own self weight, right? Along of this line here. It also have a brick wall, let's say along of this line. So that means there will be a uniform load along of this beam. Daripada sini lah you come out dengan estimation loading from the punya sketch, kan, of the load distributions here. So just 3 columns here to support of this beam with the load that apply on it. The load from the brick wall, the concrete self weight, the slab also, the point load also. Is it enough by this that support by these 3 columns? So you have to follow the architect's proposals. Dia tak tahu pun kan selamat ke tak selamat ke, yang penting dia nampak macam oh cantik kan begitu. So we go for a safety. So kita kena analyze, is it enough only support by this 3 beam, this 3 column? Kalau okay, so you can proceed for the structural layouts, okay, according to the architect's requirement. But once you do the analysis, oh tak selamat lah kan, sini dia punya load dia tinggi sangat, moment is too high here. If the moment is too high here, we have to provide a lot of reinforcement. Kalau nak provide a lot of reinforcement, kecil sangat, beam tak muat nak masukkan reinforcement and everything. So that means we have to increase the support. Once we increase the support, let's say tadi moment begini kan, once we increase the support, kita tambah lagi support, kita kena tambah lagi column. So dia punya bending moments tu mungkin slightly lower compared to the previous numbers of column. Okay, can you understand me? Ada faham? Okay, same goes for positionings of beam here. Kan, positioning of beam, how to decides the location of the beam. So normally for the beams, okay, whenever have a brick wall, kalau kita nampak ada brick walls dalam architect's drawing, so that means that will be the line for beam. So we have to provide the beams. Let's say it mentioned this beams, all this corner here, semua corner ni ada brick wall. So nanti dalam you punya structural layout, so that means semua ni adalah beam. You kena provide beam. You tak payah lukis brick tu. You kena lukis beam. You just draw for your structure. So that means this should be a beam. Apa size dia? Okay. Then so this will be the beams line. Okay, according to the information, according to the brick wall information from the architect here. Same goes column. So column kita dah provide sini. Tadi kita calculate kan, kena tambah column sini kan, to reduce the sagging moments and everything. So should have a column here. Okay, should have a column here. Your structural layout plan will use until the construction. Okay, so that's mean architect just for the appearance to make sure that the building should be like this in elevations and so on, especially for its fittings, for its finishes, for its appearance and everything. But the structure, okay, should be referred to our drawing, which is structural layout span. So contractor will refer to our drawings. Okay, how many pilings and everything. Nanti nak finishings, or any fitting materials, they will refer to the architects. Okay, spanning of slabs. Remember, we have two types of slabs, right? We have a one-way slab, and another one we have a two-way slab. So you should have to determine these two types here. Okay, tapi tak perlu design slab. This design of slab will be in a reinforced concrete subjects. Okay, but you at this moment you just have to know which one that can be considered as a one-way slab, which one should be considered as a two-way slab. So I've already mentioned in last class. Okay, for one-way slab, that means the load of the slab transfers in one direction. That means it will transfer to this beam, it will transfer to this beam. Okay, kalau I buat cross sections, dah pandai kan buat cross sections. So ni this beam, and then this is the beam here. This is the slab. That means the load of this slab will transfer to this beam, and half of it will transfer to this beam. It's one-way directions of load distributions. Different with this two-way here. Okay, kalau two-way, ada dua directions lah. So that means all the corners here have a beams. Kan? So part of it will transfers in the directions, and then another load will transfers to these directions. Okay, so that is the difference. And then layout of stairs, tadi ni staircase tadi kan, you will not design, but you have to know where's the positions of the staircase. Remember, especially for the grounds, okay, dekat staircase tu there will be a slab, right? There will be slab underneath. You kena bayangkan lah, tangga kat bawah tu mestilah ada slab. You kena kira juga slab. Tapi once you go to the upstairs, let's say for the first floor, okay, let's say for the first floor, there's no slab, right? Within the area of the staircase. Okay, that means there's a void there. There's no slabs there. Okay, that means you have to ignore the loading of the slabs within the staircase area, especially once we design for a first floor, a second floor. Okay, selecting proper type of footing. Nak guna piling ke nak guna rough footing. So this is all the information should be consist in the structural layout plan. So your scope of study for this subject, so this for the column, positions of the beams, and then you have to know one way and two way beam here. Alright, so this is more details, okay, how the positions and orientations of the column are mentioned from this slide actually, okay, which is should be located near the corner, okay, at the intersections here, remember, and then selections positions of column to reduce bending moment. Now, kalau banyak columns, might be we can reduce the bending moments. Once we reduce the bendings, that means we can use just a few numbers of bar, kan? Kalau banyak sangat reinforcements in the concrete, it also will affect during the concreting works, kan? You can imagine crowded, it's too crowded, it's too many reinforcement in the concrete. It will affect the vibrations process, the concretings and everything, okay, and then we have to ensure that all the surroundings of the reinforcement also we coated with the concrete mix, kan, so kalau terlalu banyak reinforcement, that is actually we want to avoid. Okay, avoid larger spans of beam, macam tadi from this beam support by these two columns, okay, with let's say 9 meter long, it will affect the with this long span here will affect the bending stage here. So how about for the case that we just designs the beams, okay, but have three numbers of columns. So let's say this is 5 meter, this is 4 meter, right? We can reduce the large deflections or moments of the beams here, okay. Designer A design macam ni, size beam besar, reinforcement banyak. Designer B from UTHM, kan, which is Nurliana Aida, dia design macam ni, which is the best designs ever, quote lah, kan. Tak salah pun nak design macam ni as long as is fulfill all the checking, all the deflections, okay. Tapi size dia mungkin tak sama dengan Liana design. Size Liana just nice, dia kecil je, kan. Tak perlulah nak tunduk jalan, kan, sebab size dia just nice semua. Bila saya mention nak tunduk jalan tu, once the beam is too high, okay, it will ganggulah any that pass by ataupun any machines or everything, kan. Macam kolom lah tadi, columns is not flush, so you nak letak furniture pun susah sebab ada structure kat situ, kan. So what happen if that corner is smooth, kan, from brick to brick, you can just put the furniture dekat corner, kan. So that's the difference, designs, that's the effect of the size and everything, okay. So columns on property lines, so kita pun ada juga cita rasa, kan, kita pun ada taste, so kita pun nak arrange well all our structure. Let's say you provides the columns dekat sini. Janganlah lagi satu you provide macam ini pula. Memanglah as long as the beams cross the columns, right? The column still carry all the load from the beam as long as it cross each other. Tapi tak well arranged lah. So yang sini kat sini pula. So make sure that is all of the corner inner lines it arranged well, right? So that's actually that is your decisions. How good you are, how clever you are, how experienced you are. So it based on what you can produce, okay, with your designs. Oh, alamak, dah 11 suku. Okay. Okay. Ni samalah. I repeat, which is normally not less than 200. Janganlah kecil sangat kolom kan. Orang tengok pun kadang-kadang nampak tak ada rumah banglo kan. 3 tingkat contohlah kan. So dia punya columns ni nak nampak macam gah kan. Ada satu column dekat parking lot tu dari atas from the top to the bottom. Size dia kecil je. You all tengok pun macam oh scary kan. Takut dengan that small size. Actually okay je dia dah calculate pun tapi because of that size, because of that appearance also will makes might be owner pun tak rasa comfort, tak rasa selamat dan sebagainya. So there will be a standards here not less than 200. So it can be up to 200. You nak buat equal ataupun 200 times 400 tapi mostly we go for double macam ni kan. So kita pun nak structure kita nampak cantik kan. Okay, what else? So kalau halus sangat, kalau kecil sangat, so it will go into the slender. You know, the failure of the columns will have a bucklings, right? Will have a bucklings here. Okay. What happened for for the columns that have a bigger size here? Okay, we can avoid from the buckling failure, okay, or the crushings and everything. Okay, then positions of beam. Again, beam shall be provided under the wall, below the wall, or any heavy concentrated load here. Okay, so kalau nampak je wall, bawah mesti ada beam. Okay, dah terror kan. Civil student ni nak buat brick ke wak, bawah mesti ada beam ni kan. Ciwa belagak sikit kan. So ataupun any heavy concentrated load, let's say dekat roof kan, dekat roof beam, let's say dekat roof beam nak letak trusses saja. So just for the trusses you just make sure that kalau lihat trusses, kalau buat trusses in this section, this truss will transfer the load to the column. So that's mean this is the columns. Okay, this is the column. Or columns boleh atau beam pun boleh support the trusses. Trusses not give high concentrated load. Okay, sebab trusses ni let's say dia made of steel, tak ada apa pun yang duduk atas dia. It's just to put the roof system, right? Katalah ada maintenance, berapa orang je maintenance atas dia. So it's not high in a QK load actually. It's not high on the value for the loading. Okay, we just calculate its self weight of the material. Self weight pun just normally tak adalah orang buat roof concrete kan. So normally we go for the timber or for the steel. So that's why the trusses we pointed the load, we'll apply the load to this column here. Okay, let's say ada water tank ataupun ada storage, ada machine dekat roof. Okay, so might be we have to put provide the beam here. Sebab nak letak water tank kat sini. Okay, this is example below a heavy concentrated load. Dalam architect drawing, dia just tunjuk je kat sini nanti nak letak water tank. Dia tak tunjuk pun kena ada beam, kena ada slab ke dan sebagainya. So we have to provide. Okay, we have to provide. We have to know what the size of water tank, what its volume. Kan, lagi besar water tank, so berapa load kena support water tank dan sebagainya. So we have to provide the additional beam here. Okay, kata dalam architecture drawing dia mention, okay, ini adalah grade A, right? Ni adalah grade B. Dia just lukis water tank je. Dia tak lukis pun kat sini ada, memang tak ada brick and everything. You have to provide the additional grid line. Might be sometimes you have to provide the additional grid lines to show that there will be other structure on that line. Okay, there will be other beams that I propose for that lines. That means there will be additional grid line from you as a structural engineer. Let's say there will be A1 here, there will be A2 here. But the grid line from the architect maintain here AB. This is, we propose the additional grid line to shows that there will be other structure that need to be provided in this line, okay, in order to support the water tank and so on. Okay, okay, avoid larger spacings of beam from deflections is about the span. Okay, so macam tadilah, so kalau beam panjang sangat, longer spacing here, kan, long spans here, how about will affect the deflections, kan? So once the moment max is very high, katalah about 200 kilonewton meter. So numbers of reinforcement pun tak sama compared if you calculate 100 kilonewton meter. Might be ni sampai 3 bar. Kalau just 100 kilonewton meter, we just provide 2 numbers of bar, right? Okay, spanning of slab here. I've mentioned we have 2 types of slabs, right? We have a one-way slab, we have a two-way slab. So how to know that is one-way slab or two-way slabs here? You have to use of this equation, which is Ly divide by Lx. If more than 2, it will categorize as a one-way slabs. Okay, tak kisahlah in this directions ke, load distribute or in this direction, as long as the load is distributed in one-way directions. Let's say if I give you a dimensions here, Ly, it means the long span. Okay, Lx, it means short span. So let's say for this one panel of slab, okay, let's say berapa ni? Ni katalah 9 meter. Ni 3 meter. So Ly is 9 meter, Lx is 3 meter. So Ly divided by Lx, that means 9 divided by 3. So dapat berapa? It's equal to 3, right? So that means this slab is a one-way slab because Ly divided by Lx more than 2. So what happened once we calculate Ly divided by Lx is less or equal to 2, okay, which is Ly divided by Lx is equals or less than 2. That means this will be considered as a two-way directions. Okay, as a two-way direction. So you boleh calculate lah, you try lah size kan. Ni apa ni, katalah ni long spans 6 meter, ni short spans berapa, 4 meter, dapat berapa? You will get 1.2, any two ke kan, 1.8. So this value, once ly divided by lx less or equal than 2 is a two-way slab. So you have to remember of this, how to consider one way and two slab here. I put a star here because this is very important for you to know and understand on how to differentiate. Nanti lepas ni boleh je buat exercise kan. Lepas kelas ni you apply apa yang apa ni yang dah belajar. Contoh pergi ambil layout. Okay, ambil layout ni kan. Berapa span ni, katalah tak nampak 9,000, ni 6 meter, divide, so you can do your exercise. Ni you calculate, oh dapat one way kan, so this is this is two way, so that is how you do your exercise. That is how you can more understand okay from the class. Okay, so layout staircase here. Okay, you just have to know lah kat mana location staircase. You tak pergi sampai design is it comforts or not? Okay, with the apa ni levels of the steps. Okay, footing type, is it using pilings ataupun rafting and everything. Okay, so this is the footing plan here, which actually you can see here is a columns, while this rectangles here is a pad footing. Is a pad footing, which is actually is like a slab with a thickness. Pad footing. Only one thing, pad footing. So different sizing here. Okay, this is the location for the columns, okay, that you propose. Okay, which is if I draw the sections here, this is the columns, okay, that carried all the loads, that collect all the load from the whole building, from the top to bottom, and then this load will transfer to this pad footing. There will be a thickness, it must be higher compared to the slab. Okay, it can be up to 1 meter pun boleh. Okay, it depends what's the concentrated load that apply on these columns. Okay, so this load from the column will distribute to this pad footing here, then barulah transfer to the piling. Depends the numbers of piling. It also depends how many load that applied on this point here. Kalau loading tak tinggi sangat, so might be just two numbers of column. Kalau depends lah, and then also how the depth, okay, of the footing here, of the piling here. Okay, if you look at here, there's a different sizing kat sini kan. Ni kecil sikit, ni pad footing dia besar sikit. Actually it depends on what's the load on this column. Let's say this load, this column cater load of 100 kilonewtons. This load cater loads of 300. This one also 300. So that's why the size of pad footing is bigger according, okay, to the load that apply on it. Okay, might be size ni kita buat uniform. Depends lah you as a engineer kan. You nak apa ni, once it construct, once it apply at site, is it is it easy or not? Is it simple or not? Kalau you too complicated, might be you will provide the different size for all these pad footing. If you think that you want to ease the job, you want to ease the process in the constructions, okay, so might be you will do some simplicity here, make a uniform size for a similar load. Let's say this is a 250, this is about 370. Might be you can decide this point here can use the same pad footings. Okay, so this is how you decide how you ease the others jobs. Okay, so same goes for this one. Might be the load is the same here. This is a 100, this point also hundreds, and then the spacing between it is is just nearest each other, which is we can designs make it as a double pad footing here. So that's mean if I draw the sketch here, okay, so this is a pad footings, there will be a 2-point load. So design ni macam slab, okay, which is there will be a 2-point load here. Okay, compared if you want to design separately, it's also acceptable. Okay, but it's your own decision. Either you want to make your designs more simple, more understanding, is the jobs of the contractors and so on. Okay. So this is an example of structural layout, which in a structural layout, you can remove all the symbol from the architects. Dia tadi tunjuk simbol apa? Ni classroom, ni toilet, tak payah. Kita tak perlukan all the information. Kalau siapa-siapa nak tahu kat mana toilet, kalau siapa-siapa nak tahu kat mana classroom, they have they should refer to the architects. Kan, dia nak tanya toilet nanti dia punya tile sampai atas ke tak dinding, ataupun just half of the wall, they have to refer in the architect. That is not our part, that is not our job. Okay, so that's why in the structural layout plan, we just provide the structural things, the structural positions, sizings, dimensions, and everything, especially for the columns, for the beams. Okay, for the beams, what the slab thickness here. Okay, apa dia punya thickness, and then there will be details of the reinforcements that we provide. Okay, that we provide here. Okay, then if you look at here, there's a suspended slab here. Okay, there's a non-suspended slab here. There's two different things here. Okay, once you do the design, sometimes in the question we will give you an information. You have to design the beam, with a suspended slab. That means the beam will carry the load of the slab, okay, which is the slab and the column is cast together. Okay, it connect each other. So ada reinforcement daripada slab, which is connected to the beams. Okay, let's say this is the links. This is the main reinforcement of the beams, and then this is reinforcement from the slab, which is suspended. This is non-suspended, which is suspended slab. That means the slab and beam is connected. It construct together. Okay, which is it concretes together and everything lah, dia attached. Kalau non-suspended, that means the beams and the slab is separated, because sometimes the grounds, the soil properties is very high, is very good enough that can support the load from the slab. Contoh macam koridor kan. Kadang you nampak that structure, tak payah pergi jauh lah, tengok je lah F-cup ni kan. Structure, the building structure and the corridor, there will be a cracks, right? The cracks line between the structure to the corridor. That's mean the corridor is not supported by the structure, not supported by the beams. It's supported by the grounds, by the soil. Okay. Contoh, this is the beam here. Okay, this is the reinforcement here. So ada juga slab, tapi dia buat separate, which is this slab is supported by the soil. Okay, so bila cakap non-suspended slab, please tak dalam soalan tak adalah cakap please design kan. So just designs the beams with the non-suspended slab. So that means you just design the beam, the safe weight of the beam. There's let's say ada brick atas dia. Okay, ada brick kan, ada brick. So the loading is from the beam safe weight and also the safe weight from the brick. Slab ni dia tak connect pun, dia tak attach pun with the slab. So the load is transferred to this soil here. Okay, so you kena be careful lah. Either that beam support the slab or that beam not support the slab. Okay, kalau roof level, of course lah there's no slabs, right? Jangan you punya pula kan semua you nak kira slab. No, you have to. That's why drawing is very important. If you look at here, you akan nampak ada yang dotted line, ada lines yang solid line here. Nampak solid line here. I make it bigger. You pun ada slide kan. Okay, you nampak this is all the dotted line. The dotted line mean the slab and beam is connected, is cast together, is concrete together. There will be load distribution from the slab to the beam. So that's why it's dotted here. It's like that's katalah slab, this is a beam. So dotted here, that means it continuous. Okay, between the slab and also the beams. Okay, so the slab will distribute the load to the beams. So kalau nampak kat sini, it's not it's a solid lines, right? It's a solid. That means the slab is stopped here, and then there's a beam that is not connected with this slab. So that means this beam is just carried its own load. Okay, it's not carry the slab here. The slab will be supported by the ground level, by the soil here. Okay, so you kena alert. Okay, kena be careful about the symbols of once you design pun you kena stated this line. Is it you yang design kan? You nak design that slab is suspended or non-suspended. Okay, so kalau kat sini roof plan tak ada slab. So we have to provide these symbols. These cross symbols here, it mentioned that it's a void. There's no slab on that area. Okay, so that's why there's a void here, and there also portions, a part that have a slab, might be for a storage, for machines, apa lagi nak support water tank. So there's requirements to put a slabs, okay, at the roof level. So that's why for the space there's no slab, okay. Especially for the roof, kita buatlah crossing, maksudnya ada slab. Kalau ada slab, so kita maintain as a this view, okay. Nampak ni, this is a one-way directions, and then this is two-way directions according to the LY and LX. Okay, so ni there's no slab, so just make a crossing to tell that this is the voids, while this is the part that have a slack, So that's mean from the grid line C to the grid line F, from 4A to 4C have a slacks. So this is truss layout, which we designs where's the trusses, where's the main truss that we should arrange, what the spacing between the purlins, remember what is the purlins, okay, according to the grid lines from the architect. So this is all the which is preliminary element size, okay, that we have to determine, okay, of course, from the architecture's designs, okay, the size we refer to architects, okay, we refer to the drawing, we refer to the proposal from the architects. Kita okay je kan ikut size dia, as long as it's sufficient enough to carry the loads, to cater all the serviceability of the deflections or cracking. Okay, and then we also consider about the magnitude of actions or loading. So berapa load yang dikenakan? Is it okay or not with that size? Or might be we have to increase the size. Okay, so span of elements kan, so longer span will give a height, maximum moment we give a height deflections, okay, let's say, okay, and then we also consider about the fire resistance, okay, from the fire resistance we will come out what the size that is suitable for concrete cover in order to protect the reinforcement inside it. That also will affect the size of beams, okay, and then structural design experience. Experience ni lah tak ada dalam fresh graduate, right? So experience ni lah yang akan menjadikan you all ni the best designer. Macam tadi Liana propose size beam 200 kali 400. Kalau Aimi Najla propose 200.5 kali 300, tak salah pun, kan, nothing wrong with that, but how good the size of that beam that you propose, how it can reduce the cost, but at the same time you also go for the safety and so on. That is the experience lah, kan. Saya kalau nak cerita sikit, saya ada experience juga dengan consultant. Sebelum saya masuk ITSM, ada experience dengan consultant about 2 years, okay, do the designs and everything. So my first job is to design the hall, the dewan dekat kampung ada dewan kan, that can provide two court badminton. You just imagine, I baru graduate ni, I have to design the hall. I have to design the hall. Oh, excited kan? At that time I'm using Esteem. You all ada belajar Esteem?
Ada doktor.
Bukan. Saya rasa korang ada experience, ada belajar Esteem, AutoCAD tu of course lah. You also learn Step Pro. Step Pro ada?
Ada juga.
Ada juga, best lah kan, semua korang ada experience. That software, that design software is very important for you to apply nanti masa kerja. Nanti you interview kan, pandai software apa, design, Esteem kan, okay, ITSM students. Dulu saya UTM. UTM, I tak ada experience langsung. Kita tak ada subject design software langsung kan, how set on that time. Kan kita expose dengan AutoCAD. So there's no design software that we learn at that time. So can you imagine bila I masuk kerja, I kena belajar software that esteem. Yeah, it's not so difficult to use esteem, right? It's quite simple compared to the step flow. So I design lah, shock lah kan. Masa tu lah nak feeling kan. Decide the size and everything kan. Buka drawing, macam kat dalam drama kan. Pakai topi, semua lah tu. So, but what happened once the buildings construct, daripada situ I belajar. Daripada situ I rasa macam, oh malunya aku nak tengok bangunan aku design ni. Why? Okay, yang I masih ingat sekarang, I rasa macam satu kesalahan I design pada waktu itu adalah sebab bila dah construct, kontraktor dia ikut je apa kita design kan. Kalau kita cakap kalau dalam drawing tu nak 100mm, dia ikut je 100mm. Kalau dia tak ikut, nanti dia tak dapat payment kan. Dia just follow our design. Kalau ada mistake apa, dia just follow. So bila dah construct, baru kita perasan, oh next time I tak boleh buat macam ini. Okay, one of the beams that I design, okay, if you can imagine the hall, the size of beam is quite large kan, semua besar-besar sebab it's kata the long spans kan, tak ada columns pun between it, just 2 column kat hujung sana, okay, all the columns also big enough and also the beams, okay, and then one of the beam also continues to the corridor, okay, continues to the corridor. So I pukul rata lah, so I lump sum that beams with the deep size. So what happened kalau dalam hall tu it looks nampak macam hebat kan, saiz besar, sesuai lah dengan space dalam hall tu besar. But what happened once it continues, that size continues to the corridor. Okay, so that corridor pula ada yang untuk OKU tu. Ada ramp kan, ada ramp untuk OKU. That means the levels tu it's a bit higher lah compared to the ground level. So you can imagine, okay, I sketch lah, ni I punya explain. I design ni katalah beam besar lah ni, ni dah dekat columns lah. So ni dalam inside, okay, inside the hall. So this is the slabs here. Okay, this is the slab here. This is corridor. Okay, so ada ramp pula. Macam mana nak lukis ramp ya? Katalah level ramp tu kat sini. Kan untuk OKU. Faham tak korang? OKU naik wheelchair kan. So you nampak sini space between the roof beam to the ground beam is not have any problem. It's good enough kan. So proud of my design here. But what happens once I just lump sum all the size of this beam to the corridor here? There's a lack of height clearance here. Okay, tu yang bila I pergi sini, kalau I punya tinggi ni, kalau local machines lalu, okay lah lepas kan, tak payah nak tunduk-tunduk. What happen kalau Mak Saleh lalu kan? Actually diorang kena tunduk sikit, diorang kena macam hormat, respect sikit dekat beam yang saya design terbesar tu kan. So that is my the mistakes, my first mistake. Okay, my first job sampai sekarang I tak boleh lupa lah. Kalau suruh pergi balik Dewan ni, nak tengok balik dekat Dewan ni, I malu nak lalu sini. Nanti pokok lah kan, dah berapa tahun design ni, nanti orang tanya siapa yang design beam macam ni kan, tak nak mengaku. Okay, tapi as long as orang-orang kampung kat situ masih boleh lalu, okay lah kan. Okay, so that is my experience. So that means experience is very important. Okay, and then how you decide the size also. Okay, so if you look at in the habis ni any questions? Any questions?
Rasa tak ada, Doktor.
Okay, so if you look at in water systems, okay, you can refer the assignments. It's already appeared actually, okay, in the groups. Dalam group activity, okay, which is that is the assignments one, which is each of your group member kena come out dengan architecture drawing, okay. It should be double story buildings. You can also refer the instructions in the project. So I make it as a part as your assignment. Tak payah you design lain kan. You design a part of your project as assignments. Okay. So first, by this week, you have to come up with architecture drawing for double story building. Tak kisahlah housings, sekolah, factory or shop lot, anything as long as double story buildings. You can shows me wakil lah, every group mestilah lantik seorang ketua kan among your colleagues. Okay, so one of your group member can upload in the auto system, and then I will check by next week. Okay, so might be on Sunday I will go through all the group member. Ataupun kalau you nak cepat, you can just message me, okay, shows that your proposal for your architecture drawing, is it okay or not to proceed for the instructions number 2. Kalau tak approve, if not approved, so you will not proceed to instruction number 2. Okay, so I have to check your architecture drawing. Is it proper or not? Is it suitable or not? Okay, for you to use for your project, to use for your untuk come up dengan structural layout. So make sure the architect's drawing should have all the information that I stated in this class, right? So mesti ada apa? Mesti ada grid lines. Mesti ada apa lagi? It should have all the elevations, right? All the informations, what's the material and so on. Should be proper architect, because some of you couldn't get the architecture drawings from someone, daripada kawan ke abang ke kakak. Ada yang just Google, ada yang just guna Google kan. Dalam Google tu memang macam-macam you can found kan, but you have to select the best one, the proper one that can call it as an architecture drawing. Right, can you understand? Any questions based on that instruction of the assignments? Is it okay? Okay, by this week, okay, you have to upload in the auto systems, okay, the architecture drawings, and then if after approvals by me, then you can proceed with the structural layout plan. You have to position the beams, the columns, kan? That the best structural layout plan that you can make it within your group member. So by next week, I will give a list which the group member that I'm not satisfied with the architecture drawing. That means you have to find out other drawings and so on. So kalau nak cepat, so you can WhatsApp me, so you boleh tunjuk lah drawings daripada you punya groups. Then if I say it's okay, you can proceed. So that means you can upload in the auto system of that architecture drawings, and you can proceed with the You can proceed with the instructions number 2 to come up with structural layout plan. All right. Any questions? Ada soalan?
Tak ada doktor.
Okay, so I also turn on the okay. So the attendance should be submitted in the auto system. I already turned on the system. So I will stop the class right now. Okay. All right. Thank you, everyone. Don't forget to submit the attendance. For those who not submit the attendance, I assume there's you absent the class. Okay. So thank you, everyone. See you by next week.
Thank you, doktor.
Okay. Bye.